Hello, everyone. My name is Andrew Will, and I have done my data analysis report on anthocyanin concentrations in two different plants. Over here, I have posted a picture of an organic structure of how anthocyanin looks, and as you can see, it is pretty complicated. The main takeaways from my study were I found the average value for 4 Begonia grandes plants and 23 Dendrothemia grandiflorum plants. The average values I obtained were 2.8375 milligrams per grams dry weight and 4.882 milligrams per grams dry weight, respectively. I also conducted a t-test and obtained a p-value of 0.56, which is greater than the significance value of 0.5. Since the p-value is greater than the significance level of 0.5, I concluded that there is no significant difference between the average value of anthocyanin concentrations between the two plants that were studied. Over here is the figure I have put together comparing the two average values I found. The Begonia grandes has an average value right here, and this is the average value for the Dendrothemia grandiflorum. As shown, the Dendrothemia grandiflorum has a higher average value. However, there are lower error bars due to the larger variation in the data as compared to the Begonia grandes plants, with a p-value of 0.56. My methods is for article 1, I pulled the average values, the values for the P1 to the P4 data, as shown here in the bars. And then I estimated the anthocyanin concentrations for the P1 to P4 plants. And I obtained the values by taking an average of the four values and receiving a value of 2.8375. To calculate standard error, I had to propagate the error and estimated the error bars in the anthocyanin concentration bars. And I had to propagate my error by squaring the standard error values for each plant, adding them together, squaring them, and I got an error of 2.09. Over here, I have shown how I calculated my standard error. For article 2, I was given a table with the values of 23 different plants. I added all the 23 values given in the table, divided by 23, which is a sample size, and obtained an average value of 4.4882 milligrams per grams dry weight. I also calculated my standard error as done before by propagating the error and adding all the plus minus values given, squaring the plus minus values, finding the sum and taking the square root of that, and I obtained a standard error of 1.042. You might ask why this matters. Studying anthocyanin concentrations is very important to study the pigmentation on flowers. Anthocyanin gives rise to pigments, and which gives rise to colors like black, purple, blue, red. And by observing anthocyanin concentrations, we can further study plant pollinator interactions and chemical signals or cues that flowers give off to attract pollinators. Furthermore, flowers can use their color to defend themselves against ultraviolet radiation. Anthocyanin has many health benefits due to the rich antioxidants and are often used to help boost your immune system, prevent chronic diseases, or used as inflammatory agents. Many of these anthocyanins are found inside of herbal teas and medicine. Over here, I found a quick infographic showing anthocyanin concentrations in foods we eat probably on our daily lives, such as blueberries, pomegranates, corn, raspberries, grapes. All of these are good sources for anthocyanins. That concludes the end of my presentation, and below I have posted the citations that have made this study possible. Thank you so much and have a great day.